Solving Systems of Linear Inequalities by Elizabeth and Jack. So our problem, it's obviously not in the correct form. It needs to be in slope-intercept form. Right now we have x plus 3y less than negative 6, and we have x minus y greater than negative 2. So, step 1. So since it's not in slope-intercept form, we have to isolate the y. In order to do this, we are going to subtract x from both sides. So this leaves us with 3y less than negative x minus 6. Now we must cancel out the 3y because we want the y by itself. In order to do this, we are going to divide by 3. This is because what's happening right here is it's multiplication. So in order to cancel that out, we are going to divide. And our result is y less than negative 1 over 3x minus 2. Step 3. So this is our second problem, and it is x minus y greater than negative 2. Now we're going to put this into our slope-intercept form. So we subtract negative x, and we get y greater than negative x minus 2. These are both of our results and are now both in slope-intercept form and can be graphed. Now moving on to graphing, here's some things that we need to know before we graph these inequalities. So to graph the line, solid, if it has that equal to sign underneath, and dotted will be it being greater than, less than. So now in order to determine the shaded area, above will be for the symbols that are greater than, and below will be for the symbols that are less than. We are going to graph our first inequality, so it is y less than negative 1 over 3x minus 2. Now, so our 2, that's our y-intercept, will be right here. We then go down 1 since it's negative 1, and we move to the right 3 times, which leaves us putting our point right here. This is a dotted line since it is less than, and we're shading below since it is less than. Now our second inequality is y greater than negative x minus 2. Now this is going to be dotted as well since it does not have the equal to underneath, and shade above since it is greater than. Now, in order to determine our solution, what is our solution? Our solution is the overlapping region of points that satisfies both inequalities. Now, when we graph both inequalities, you can see that the area where they meet is right here. So this is where the solution lies. Any point in this area is a solution.